Hi, everybody. Thank you so much. I'm sorry we had some technical difficulties. That's technology these days. So let me start again. I'm Kaisha Gabriel, the North American Field Marketing Manager for Kelton Tech. Thank you, all of you, for your patience. And hopefully that will be the only glitch we have this morning. Anyway, today's topic is going to be IoT implementation and security best practices. Let's go over a little bit of housekeeping. Should you have any questions during the presentation, please type them into the Q&A section of the control panel, and we will address them at the end of the webinar. If we do not have time to respond to all of your questions live, don't worry. We will respond to them via email. The session is being recorded and will be made available to you via email a day or two after the webinar. Now I'd like to introduce our speakers for today's session. I'm honored to have with me today Sushil, Tripathi, and Nishant, Singh. Next slide, please. They are well-known thought leaders in IoT with over 15 years experience in this domain. Sushil is a seasoned IT professional with vast experience in disruptive technology implementations. He has helped many startups to bootstrap and scale, as well as leveraging his deep understanding of various technologies and domains to help enterprises transform digitally. Nishant Singh is a digital transformation expert with a strong understanding of IoT, backend development, integration services, and mobility. He has worked with countless companies ranging from startups to large enterprises to transform their business operations using innovative digital solutions. We are excited to have them with us today, but before I turn the presentation over to Sushil and Nishant, I would like to begin with a brief corporate overview. Kelton Tech has been a pioneer of digital transformation for the past decade. We have operations in North America, Europe, and Asia. Our clients range from startups to Fortune 500 companies, with a core strength supported through our ISO 9001 certification and CMMI Level 5 compliance. Kelton Tech is 1,500 plus employees strong and is a publicly traded company. Next slide, please. Kelton Tech is a new age global IT services consulting company. We design, develop, and operate digital technologies that create new business models for our clients. We offer digital services across 5 major pillars. Digital systems. Our digital services span IoT, social, mobile, analytics, and cloud-based solutions. Digital integration covers integration services in support of your digital systems. Systems of record, enterprise application services across SAP, Oracle, and Microsoft solutions. Outsourced product development offers custom product development and support services. Our digital commerce and marketing delivers omni-channel e-commerce solutions focused on improving overall customer experience. And finally, IoT-enabled platform solutions offer IoT solutions for oil and gas and the manufacturing industries. Now, let me hand the presentation over to Nishant, who will start our official topic discussion.
Hey, thanks, Kaisha. Hope you can hear me now, right?
Yes.
Yeah, okay, great. So thanks, everybody. Thanks for taking your time for this webinar, and I'm sorry again for the glitch. So, let's quickly, I'm going to run a few slides to set the context about this webinar, what's the agenda of this webinar is, and then I'll hand over the slides to Sushil. So the reason that why we decided to come up with this webinar, because, over the last 5-6 years, we did some good IoT implementations, and we identified that the companies want to get benefit of IoT. They want to get benefit of automation, but some of them don't understand from where to start. What should be the right approach? They are too concerned about the security risk. They're concerned about the ROI. So in this webinar, we are going to cover all this. We are going to discuss integration with the legacy system. We're going to discuss IoT adoption, how to make it simplified. We're going to discuss the practicality of IoT solution, how actual the IoT implementations look like. We are going to talk about ROI from IoT adoption, and we are going to discuss how to mitigate the risk that's come arise with any changes. But before we go on to all this, let's understand what is IoT. I'm sure that most of you understand in theoretical what is IoT is. So name suggests it's Internet of Thing. So when I say a thing, it's a device. So when a device is connected via network and able to collect the data and send the data to the main control panel, or you can say the cloud, for a processing using a network. And in the cloud, some processing take place, and out of this analysis and processing, a meaningful information, meaningful conclusion comes out, and the cloud system is able to send the message or send the command back to the device, and the device able to receive that command. So that complete the entire structure of IoT. So IoT environment generally consists of sensors, a communication channel, then computation over the cloud, and ultimately the final result. If we take few examples, predictive maintenance, connected car, connected fleets, wearable devices, all these are the examples of IoT. So when I say the predictive maintenance, let's take an example of a farm. So when we say a farm, so sensors are attached to the farm or a particular tree or a particular plant. So they guess that, okay, this collect the information and send the information to the main control panel. The control panel analyze that information and decide that, okay, this particular plant require 2 liters of water. But that particular control panel is also connected with third-party APIs that is going to give the information that tomorrow there can be the rainfall. So that's come the predictive analysis. So it can predict a rainfall. So the central system is going to command to the device that, okay, just give 1 liter of water to the plant. So there can be n number of use cases in this. Nowadays, digital twin is very popular. It can be used in defense sector. It can be used in areas where there can be the life hazards, or there can be, which is difficult for the humans to go there. So digital twins can be used over there. Now, all of us are representing some business house here. So the main concern of business is to generate revenue or to start a new stream of revenue. So how we can use IoT to start a new stream of revenue that we are going to discuss in next 2-3 slides. First thing is that we can launch a new product using IoT. That product can be on a service level, that product can be on analysis level, or can be on integration level, or it can be altogether a new product with a new innovation. So launching a new product using IoT can definitely open a new stream of a business, like we did for one of our clients. They deal in access management. So we just they just launched a connected digital locks, and that's just opened the new revenue for them, and they are doing very good from the last couple of years. Now, what should be the success factor when we are talking about IoT implementation for a new product? Because if you are going to use IoT, it's going to maximize the product fit with customer requirement and need. It's going to minimize time to the market. It helps us to identify the market trend easier and faster. Why so? Because IoT is all about connected device. It's all about data analysis. So if you do have the information, it helps us to cover all this point and ultimately get a superior product that will differentiate us from our competitors. Let's take a few examples. Let's say if somebody is doing into event management. So there can be simple beacon-based solution that can be implemented, which can be attached to the guest so that they understand the guest behavior, in which particular booth they have devoted much time, in which particular category they have devoted much time. And based on that, somebody can approach them that, okay, you're looking for that solution. So we will get an idea about the guest behavior using simple beacon-based solution. A new solution, a new product can be launched in oil and gas industry. Let's say we do have a product called Optima that's to end-to-end asset management, operation management, resource management, predictive analysis. So this kind of solution can also be launched. If we talk about food industry, so we see lots of wastage is taking place in kitchens just because the item get perished. So if we have a real-time monitoring of a perishable items, that can save lots of wastage that can save loss of human time, and ultimately this is going to boost the revenue of a business that deal into food industry. So that can be one of the new product that can be launched using IoT. Now, in certain scenarios, it's difficult to launch a new digital product. So what can be done? How the IoT can be beneficial in that cases? So IoT can help in the optimization of the current process. Be it on a preventive side, be it, if you talk about quality and building performance, be it enhancing productivity or optimizing energy uses. So IoT in all can help in the optimization of a current process. Let's say in a banking industry. So nowadays, lots of AI-based chatbots are there, which are there for user satisfaction, making the customer experience better and faster. So ultimately, it's optimizing the performance of a bank because the users are satisfied and they can and they are saving some good amount of time and the resources, the manual resources, human resources, so they can utilize these resources in a better manner. If we talk about manufacturing and oil and gases, IoT play a big role over here, because manufacturing and oil and gas industry, lots of layer of communications are there. So human error are can't be ruled out. So if we are going to use IoT in oil and gases, it can definitely help in optimization of the performance. Let's say if there is a leakage in certain part of a plant, so IoT can detect that particular leakage and send the information to the central control system. Now the control system can decide how severe that leakage is. They need to shut the complete plant, or they just send some mechanic to solve the problem. So ultimately, IoT is optimizing the process. Now there can be a third scenario where the organization don't have anything to do with IoT. They don't want to get into hardware. They don't want to get into sensors. So how they can leverage the benefit of IoT? So some of you might be into e-commerce industry. Some of the attendees might be from e-commerce industry, or they wanted to get into that kind of industry or marketing industry. So what they can do? There's many third-party the APIs, third-party data providers. Let's say for a retail industry, there's a company who set up a process with the sensors using cameras. They are collecting the information about the user behavior. Let's say a user pick up a shirt and he's very happy with the shirt, and he tried a number of shirts, but actually didn't buy any of the shirts. Now we find that, okay, why he do it? Because of the price factor, because he's looking at the tag and he just dropped his buying decision. So as a marketer, what they can do, they can plan a targeted marketing campaign by based on the data that they receive from that retail store, so that they can going to push the similar kind of the shirts with a lower price tag. So this is one of the wild example. There can be a number of examples where third party data can be used for targeted marketing campaign or targeted campaigns to enhance the productivity or enhance the business or the revenue of your business. This is the example that I just gave you. Now, talking about the technicality of IoT, the risk issues and the implementation part, I'm going to invite Sushil, who is the smart one here. So Sushil, can you join, please?
Yeah. Thanks, Nishant. Thanks for setting the context. So here for the IoT solution architecture, so if you see, that means it is nothing new into the system. That means the system used to exist already, but now the systems are more standard, and because of the advent of the cloud and all these newer technologies, so now it is much more easier to like present a reference architecture for the IoT technologies. Otherwise, people used to do it in a different manner, different type of technologies being used. So here, generally, if you see, that means there are like 5 layers of the complete system, where one is the device layer, where actually your devices, sensors, your gateways, aggregation gateways, those come into the picture. Then you create the digital twin of those devices, and that data is being stored as a digital twin onto the top servers, your cloud servers. And then you have a communication layer. So communication layer, definitely it can be any of the, like the LoRaWAN, or like it can be any of the mobile networks. It can be your broadband and all of those things. Generally, that means it depends on the topology and the network architecture that you are using. And definitely in the terrain you are using, it can be a satellite communication also, because now a lot of like those providers, they come up with the like small satellite chips that your devices can directly communicate to satellite also. Then information layer, where actually all of your data and event models are there. Those are modeled and data is stored, and the augmented with metadata, there is data about all of those systems, or even it comes as a, like where you get the data from external systems also and stored for the further analysis. Then you have the function layers, where the uh, especially in the case of like real-time processing of the streams, and even you're enforcing the policies, and sending it to other systems, analytics algorithms and all that, and then using machine learning. So this layer is actually, that is whether you are using Apache Storm, Spark, AWS Kinesis, any of those systems that means you use, or Lambdas. Then there is a process layer, where it is actually the governance, the operation, management, your business applications. That means on the top of that, you create all those business applications, mobiles, things, and all that. So all of that come onto that layer. So that is broadly, if you divide all these things, that is the edge tier, and then so edge is the device layer actually, that is the edge, where then platform tier and then enterprise tier. So platform tier is, that is any IoT platform that you are using, and enterprise tier is, that means your enterprise business logic, your enterprise applications being using the system. Next slide, please. So suppose like most of the like time, what happens with the organizations or enterprises using already, like they have a lot of legacy system, they have SAP, all those systems, and when they onboard IoT, so they need certain data in a different forms to be submitted to those core systems also, so that for the further processing and to business, to run the business workflow actually. So suppose take an example of like a food joint that uses IoT for a big food joint that uses IoT for monitoring the temperature of the freezers, and they are maintaining, suppose the HCAP recommendations. That means you need to note down the temperatures and all for periodically, so that you meet the compliance that this food has not gone below the temperature of like this specified temperature, those kind of things. So either you employ a person to note it down periodically, or you have an IoT system that automatically monitors that, like a special thermometer, IoT thermometer placed inside your freezers, and it is automatically monitoring. Or you have the newer systems, those are already IoT enabled, newer freezers, and those are IoT enabled, and now you need to feed this data to your core systems for the compliance report generation and all that. So in that case, the problem comes where, that means when it is like the number of devices, connected devices, is increasing, and if they start doing the concurrent data exchange, then that becomes a problem for that legacy system. And generally those legacy systems are like built on around the batch data, and they refrain from the stream messaging. and in that case also, so you need to have some buffer before those systems, and then integrate it, and at the speed they can process, you need to give them according to that in those batches. Then other thing is like generally there are fixed number of endpoints, that means those are on premises deployments, have the scalability challenges. You cannot expose them outside of your firewall system, or even a cloud system cannot get into your firewall, inside your firewall. So suppose you took an IoT solution that does this temperature monitoring, or suppose that does a refrigerant leak detection in your supermarket, and now the problem comes that how you are going to allow that system to communicate to their own server. Suppose it is a SaaS based solution or something like that, you need to do a lot of provisioning inside your firewalls. So those are the challenges when you actually integrate a legacy system with IoT. Then latency, throughput, if you can actually like count so many problems, those come there. And the protocols, because so are they able to support those protocols or not? Sometimes there are some of the solutions, those come with the suppose UDP and all that, and those UDP is not allowed in your system. And then some of them come with the AMQP and all those type of protocols, and your system is not supporting that. It cannot subscribe to MQTT and all that, so you need to have different integration layer for them. And as I already said, that means the on-premises hosting and getting all of those security challenges actually gives a lot of problem. Next slide, please. So whenever you are going to do the implementation in your organization and for the IoT systems, so definitely you need to choose according to like multiple things. One is definitely your use case, and if something fits on your use case, then definitely that has to be there. But there are some technical problems also, like choosing the right protocol, because it depends on like which type of application you are using, what is the frequency of the data exchange, what is the requirement, or how frequent the requirement is for device provisioning, and then updating those device firmwares and all that. According to that, you mostly choose for your protocols. So HTTPS is that means that is also a TCP based protocol. MQTT is the most popular one being used in IoT mostly. It is backed by TCP, so it comes with all those TLS securities and everything. CoAP is like mostly used in the systems like where you are using the mobile networks to communicate to your servers from your devices. There you need to use, because it is a constrained protocol, and definitely that means you wherever the connectivity is jittery and all, so it is a good, so it works on user datagram protocol. And this is like, so if you require communication through the mobile networks and you need a CoAP protocol, then you need to be careful in choosing your IoT partner, IoT implementations, because many of them do not provide the support for CoAP. Similarly, MQP, ZigBee, all these protocols, that is wherever which type of connection you are using. As I said, LoRaWAN is one of that, where you are using a wide area network to connect all of these system to your hubs, and those hubs are talking to the cloud systems using like normal MQTT or even it can be HTTPS protocol. Then security is always a concern. So you might have heard a lot of news about like the IP cameras getting hacked. Even Alexa started saying something else, and a lot of systems. Those are like right now. If you remember the Mirai botnet kind of thing, where a lot of webcams were hacked, and those kids actually used those webcams to generate so much of the traffic, and were able to brought down Netflix for 7 minutes. So those type of like vulnerabilities used to be like, so sometimes it is coming with the hardware itself, with the hardware firmware is not updated properly, or like it is an outdated, and because it is a free one, most of the manufacturers are using it. So those type of vulnerabilities are also there. Then legacy integration, definitely, as we have already talked about. So legacy integration, how well it integrates with the legacy systems, how many integration points it provides to you, how many integration adapters are there, will it be able to integrate with those systems or not, you need to take in consideration. And then scalability, definitely you start with a pilot, and when you start adding more and more sensors and trying to reap the benefit, the system should be able to support it. Otherwise it becomes a challenge for the scale, and then all the initiative actually falls apart. Next slide, please. So it is a like sneak peek into the development platforms, IoT development platforms, and even that means there are many platforms already. Like on, if you search for, you will get hundreds of platforms. But some of the prominent ones are like Microsoft Azure IoT, Amazon Web Services IoT, Google Cloud IoT, and Software AZ Cumulocity, and even ThingWorks, and then some of the open source ones like Device Hive, and all of that. Even you have Device Hub, many of the other some of the electronic companies have those type of IoT platforms also, like Tuya, and many of the companies from China also have a lot of IoT platforms, and many of them are plug and play. That means you can go for that. But if you are taking a strategic decision where you want to implement your own IoT solution, then definitely you can choose from these IoT providers. Next slide, please. So strategies for the integrating legacy system with IoT. So there can be like three type of, like, when not only the legacy system, even like when you want to implement an IoT in your organization, then you need to like find out that what is your time to market, what is your objective, are you going to need a multi-tenant system or not. So according to that, you are going to choose the right platform. So one is like, option is always like building from scratch, where if you're building a custom solution from scratch, where you can like go and use all those systems available like in the open source domain, and like using HiveMQ or EMQ for as a gateway, and then building on the top of that all other systems. And you need to do a lot of work, and then you need to take care of the scalability and all those building from scratch problems used to come there. But you have a lot of control onto it. Then wrap and extend. So this is one of the like I would say if you want to have a product offering around IoT, then it is one of the like very good options where you take something like Microsoft Azure or AWS IoT or Cumulocity, Google IoT, any of them. And though like Microsoft Azure provides you infrastructure as service, platform as a service, and software as a service also. And similarly, Cumulocity provides you all of those type of things. It is mostly PaaS and SaaS kind of thing. So you can take them and you build on the top of them and use them as those as the backbone of your the IoT system, and create all those front end and business workflows and multi-tenancy and everything on the top of that. But the heavy lifting is being done definitely by those backend systems, and you are just wrapping it and creating on the top of that. One other option is buy off the shelf, where if the product is already like in the same domain and it fulfills most of your requirement and you need less time to market, definitely you can go for something buying off the shelf. And though the problem comes with those things is like the customization and all that, how if it will be able to meet your future needs or not, you need to check for that. Next slide, please. So if you see, these are like comparisons that we put on, that means where compliance to standards, if you are building from scratch, so you can put it like whatever compliance is needed, you can start coding it, though definitely it takes time. And wrap and extend, they come up with certain compliance, so the compliance that is not met in that, either you try to mitigate or meet in your implementation, or that means you need to talk to the vendor, that means how you are going to meet that compliance and who owns it. And buy off the shelf, there are also restrict compliance, that means whatever compliance it comes with. If something new comes, definitely if it is a vendor and renowned vendor, so they are going to release something new, a new version of that to do the compliance. But mostly that means you need to wait for them in wherein when you are building your own system completely, so you can actually start just like upgrading it, building for that. Then time to market, definitely building from scratch actually takes a lot of time to market, while wrap and extend takes medium, and lowest is the buy off the shelf. But definitely there you might need to do the compromise on the features and functionality. But for like launching for a minimum viable product and then customizing on the top of that, it is a good option. Then interoperability, definitely when you are building from scratch, so you can do all of that. And both wrap and extend, buy off the shelf, you need to like look at how they interoperable and how they are going to integrate with your system. Scalability, generally that means building from scratch, once again it is up to the performance engineering of the team, that means how they engineer it. But yes, it can be created mostly scalable. Wrap and extend, once again all those backend backbones are already like very scalable and all that. But once again, whatever you are building on the front of that, that means any component if you are introducing, whether that is scalable or not, you need to take care of that. And buy off the shelf, once again you need to go with the benchmarks provided by the vendor and look at, that means what is the benchmarks and whether it fulfills your requirements or not. Then maintenance, as then if it is building from scratch, then definitely maintenance requires like high, it is high because you are building everything from scratch, so you need a good technical team and all that to monitor it, to maintain it. Wrap and extend, definitely only the additional functionality, the additional wrapping that you have done, you need to do the maintenance. So it is medium maintenance, and by off the shelf, you need a low maintenance, because generally those are built in such a way that they are going to release, those vendors are going to release the new versions and all that, and you need to figure out the licensing and all that for the updates, further updates and all. And the level of customization, definitely you are building from scratch, so you can do a lot of customize. So if you see, even there is a trade-off between uh, build versus buy, and building from complete scratch. Here third one is the wrap and extend. So if you are like completely, you want to own the complete IP, and into like you are a startup, so building from scratch is the solution. If you are an enterprise starting a new business, want to launch it faster and still don't want to have a fat technical team, wrap and extend is going to help a lot. And if you don't want to have much more like technical teams, and you are not going to like, so wrap and extend is something like where you are providing new offering to other businesses, and multi-tenancy and all that. Buy off the shelf is like, it is mostly if you need for your use case and all that, so it is very good in that case. Next slide, please. So like IoT enabled logistic solutions, the use case, that means that we also worked earlier on to these. So smart fleet management, where that means you have the sensors and the GPS locators inside the fleet of the vehicles, and you locate, you can locate on the map, and do the optimization. So right now, that means one of our client was like, they were into the logistics generally, that means where they do a lot of cargo shipping and trucking and all that. So the route optimization problem and all those type of things, it is, you can think of like just like uberification of that inside your organization itself, like how they plan for the ride sharing. Similarly, you can plan for their route optimization, where they can go for like how they need to pick up the consignment, and what routes should they follow to deliver it. And then when they are actually like coming back, that means how you should plan their route and pick up and all that, so you can optimize a lot. And definitely you can actually see the driving pattern tracking, track your drivers, how they're driving, and all of those type of things also with different sensors. And your mainly second is like, you can do a lot of like asset monitoring on IoT enabled, even like your container having the freezes and all that, where it needs the compliance, so you have those IoT enabled thermometers placed into that. Similarly, you can monitor, like suppose you have the RFID based tags on the crates, or those boxes, those are loaded into those vehicles, and how many of them has been unloaded and all that, you track that. So a lot of things like those are possible that you can actually do the in the logistic solutions. Next slide, please. Okay, data security and privacy in IoT. Um, okay, so data security and privacy is the most important part, if you see, because of these like increasing number of the IoT devices. The biggest threat is the security and privacy, because if you have suppose a camera, and if somebody sneaks into it, and can then see all the live streams and everything from that camera. So there you need to be like very careful, and when you are implementing these type of solutions, so those have to be secured. Those have to be secured with the with the transportation layer also, at the access layer also. It should not be able to like it should be tamper proof kind of thing. Okay, so one thing is like you need to handle that data. And now if you see the compliance of like GDPR kind of thing coming in Europe, and those are also like have to be has to be considered, and accordingly you need to plan your security architecture. And then insecure communication, definitely many times it is like insecure network that on which you are transferring the data, and the network is not secure. Even if there is a TLS level security, but your that local channel, that means, so TLS level security is from the hub to the server, but your local network, local wide area network, that means the WAN, is not secure. So there also it can be lead to the security breaches. So you need to have a security policy and enforcement and a SOP against the security of those devices and those communication channels. Then data security, definitely, that means a lot of like IoT device manufacturers, they actually do the exploitation from the data collected by those appliances and devices, and they understand the consumer behavior and their users pattern, and try to like it can be used in any manner. It can be, though it can be disguised as that it is for the system performance and all that, but definitely if you are taking those devices to be used and all that, so make sure that they are not communicating to any other system to actually like sending the data to those type of servers where that data can be exploited. So definitely it is very much necessary to understand that. And many times if your business is something where you are into device manufacturing itself, and then or you want your customized device to be manufactured, then make sure that your manufacturing partner does not have something like that. Okay, next. All right, then it is key challenges for data security and privacy in IoT. So one is the multiple point of vulnerabilities, where each connected device assets represents a potential risk. That means there are number of devices and risk can come from anywhere. Then once again, the transport layer security, the encryption, all those things, because end devices sometimes like those don't have that type of processing power and all, and those are dumb enough. Only they send the data, but they are not able to encrypt it and all. So you need to be careful onto that. And definitely now, because of the newer infrastructure and newer technologies, now very small devices also are capable of like doing those type of encryptions and all that, so you should take care of that. Then data integrity, that means all collected data should be checked for compromise. That means that they should not be compromised, and nothing should be altered. So you should be using the proper signatures for that data being collected, and you can use any of like those security techniques like cryptography to make sure that, or hashing, sending the hash and comparing that hash with those hash generated through the secrets. Then vulnerability management is like, it is difficult to assess the repercussion of the vulnerability. It is even difficult to find out the vulnerabilities, and if you are able to identify then how to mitigate that from those risks, how to do that, and how to update that, because you might be dependent on multiple vendors and even some of the like outdated contracts, outdated vendors, and that becomes a difficult task. Then update management, that means large number of devices need to be updated, as I said, every time if any new firmware comes and all that. And there might be like multiple versions of the devices for you as you roll out like your over the period, and the older devices are not supporting those new features, new updates, and then you need to actually run with the multiple versions of those systems, and then that becomes a challenge. Then carelessness, definitely user ignore the security issues and user do not perform basic steps. So to ensure the security, that is also like a challenge where you need to actually have a very strong standard operating procedure for the security in your system. Next slide, please. Why should you worry for the security thing? So you can think of like a hackable connected cardiac device. That means, so the researchers actually found out that even the cardiac devices like pacemakers and defibrillators were hackable, and the FDA said that hackers could break into those devices and deplete the battery, causing incorrect pacing. So that means the pacemakers are connected, and suppose it is being hacked, so it can like it can increase the heartbeat, or it can like suppress the heartbeat, and that is a fatal thing for a person who has these type of devices implanted. And similarly for the IoT enabled cars, connected cars and all that, somebody hacks into your car system and then changes with the configurations can make you like that means can damage a lot of things, even can be life threatening in case of like if it controls the speeds and all those type of things, because nowadays everything is connected to the chips, computers, and in the cars itself. So it can be very, very dangerous. Then strategies to ensure the data privacy and security. So you can form a lot of like all those securities and all that, and I would say that means those are the same strategies, those come from the earlier systems, but here the challenge is bigger. And so you need to do a security architecture design, then firmware and app security, then selecting robust protocols and secure infrastructure selection. And there, that means security architecture design, you need to actually do a lot of like get the recommendations from the experts. Then you need to do a deep security analysis and evaluation for your system, do a lot of penetration testing, see all of that, and then you need to actually see, that means if you need to do some of the, if you are using an open source solution, because there are a lot of like open source software being used, so you need to do a source code audit and edit it if necessary, for like change all those type of like points where it can be hacked. Then definitely you can use technologies like blockchain or anything like to implement the audits with the cryptographic keys and all that, so that you are able to like uh, uh, you are able to audit it and find out the vulnerabilities and all. And assess wireless protocols, and which protocol you are going to use according to your need and the security requirements. And you need to like design your system with the limitations, that means within the boundary of those limitations, that means the protocol actually gives, and design the security accordingly. And definitely you need to get a secure infrastructure. That means the data center or the cloud providers that provides ultimate security for those systems. And definitely that means you can do all of those audits and select the robust protocols where you are not like just transferring on a plain text manner and sending the data to the system so that it can be tapped into it. So you need to find out the right protocols, even the right communication data formats also. Next slide, please. And then you can do all those type of things like device security, software security, and key management. So here, if you see, that means data privacy and security. So these are three fundamental things. One is the device security, the physical security of the device. It is very much needed. So how you are going to safeguard your devices from physical access and being tampered. So either like implementing something like those type of physical and electronic locks, where if something goes wrong, they wipe out their configuration and all that, so that those cannot be altered or the data cannot be stolen from them. The software security, definitely you need to do a lot of application penetration tests, a lot of like those scanners, those source code scanners and all that, those should be used, and at least certified if you are using a vendor. So it should be certified with those security guidelines, top security vulnerability against top security vulnerabilities. And then key management. So definitely most of the time many of the hacks actually come through the leakage of the keys of those systems and keys and credentials. So you need to have a strong key management setup, either using the hardware based key management or having a strong process for the access of those keys and make them secure. Next. Okay, so this is like once again attack countermeasures. That means, see, you whatever you do, whatever you try, still there can be the attacks and you might be targeted. So one is you need to create the capability to the technical countermeasures. In the case of any security breach, you should be able to isolate those systems from the rest of your network, rest of your system, so that the vulnerability actually resides within that, like it is quarantined, and then you mitigate the vulnerabilities. And then definitely you need to do how you can do the sanitization of your complete system, and how because you need business continuity also. So how fast you can actually recover from that type of attack, that you need to talk to your vendor, you need to, or if you're developing in the house, you need to uh, have that type of capability and develop that capability to do that. And definitely you should have a backup plan for that. Next. So IoT enabled manufacturing solution, one of the use cases where that means you can do a lot of facility management, as I already like talked about. That means where you have one example is the temperature monitoring, but you can have multiple things, like where you have all of your plant. That means many of those, even older plants, actually they come up with those hard sensors, and they transmit the data in analog form. If you want to modernize them, have some of those like hard to digital converters, and then have those things to be streamed. Those that data is streamed to the to the gateway, and then from there to the cloud, and do the analysis about your like you can do the predictive maintenance. You can even like operate that using those modernized systems, using just like sitting on anywhere, And even one of those things are like, suppose you are running a data center where you need to control the temperature and cooling and all that, and since every bit of energy saved actually gives you a better revenue, because and better profit, so you can do that. Then quality assurance solutions, you can actually do that, like product composition ratio monitoring and alerts. One of the solutions that we did for one of our clients, where uh, they they used to get deformed products sometimes onto the conveyor belt as the output onto from their assembly line, and they wanted to make sure that it is in proper in shape. So uh, uh, and identify that how many have come and all that. So we created a solution that is put on the top of that, and can found out that form factor and solution. And then actually if there is a defect, so definitely there are humans to pick them up and do the manual inspection. But if the system can itself detect, then it actually increases the productivity of the complete system. So okay, practicality of the IoT solutions. uh, Next slide please. So an ideal implementation roadmap of an IoT solution is, definitely the problem comes like whether it will work for me or not. So it is always better to go for the IoT implementation feasibility workshop, where you actually do a workshop where you assess your system and then find out whether there is applicability of IoT or not, what ROI you are going to get from there, and and all that homework you need to do. And you can take the help of any implementation vendor also for running that workshop, where the need analysis and all those type of things can be done. And then you do the strategy planning, that how you are thinking and what is your even revenue model and all those type of things, and even what makes sense. You do the strategy planning for how you should go for it, and then you develop a business case, which business case is the most suitable. So you, in the workshop itself, you have find out the feasibility. You have already discussed a lot of business cases, but find out the I would say the most impactful business case, because you need to actually get the that on everybody's agenda in the company also, and you need a executive sponsorship also for that. So always choose for the bigger impact, and bigger impact but yet simple to implement thing, and that would be a much better option. Then you create an implementation roadmap, start a pilot, do a pilot, run it, refine it, and then if it makes sense and you are able to, and you can run multiple pilots on multiple business cases, and whichever you find the best, you start the implementation of that, and then scale that solution for the production. Next. So our experience, so similarly, so we actually work on the similar type of like flow, where we start with the workshop. And so one of our client that he was like Nishant was talking about, that they are like one of the like on the premises access control uh, into that into that domain. So we actually developed a multi-tenant system for them, where their clients can use it, and it is on based on cumulosity, and where we have all that IoT device management, device provisioning, then implementing the device twins, and taking all that data, then going deep into like even using the some of the like mobile phones and all that. You can actually go and use your logs. lock and unlock. So those type of things where we actually conducted a workshop, understand their system, what they wanted to do, and how it is going to work. And then we created some of the high-level use cases and solution architecture for that, selected the platform and all those data flow and security and all that we discussed. And then next slide, please. Then definitely we created the strategic plan, and after that we developed the business case for that, and then created an implementation roadmap. We defined all those phases and timelines and defined the platforms to be used for development and those protocols and all that. So there was a lot of like back and forth about like which protocol is we are going to be using, whether our devices are always power connected or not, what is the power consumption, and according to that we decided the protocols. And then finally we created the pilot project, and the pilot project was very successful, and then we actually updated our implementation roadmap according to the findings from the pilot project, where there was a need of like even getting the data from the server to the device, where initially we were envisioning only the data is going from the device to the server. So those type of things we got as the feedback from our end clients. Next slide, please. And then we started implementation, where we created the development level product, then production level product, and then feedback incorporation and end-to-end solution deployment. And then it goes into the normal cycle of the change management and all that. And finally, the solution is scaling. That means testing it for the scale and deploying it in different business verticals, and monitoring it and tweaking the performance of that system according to the need. Next. Any questions, please?
Hi, Sushil. That was wonderful. Thank you so much for the valuable information, Nishant and Sushil. And we've had a couple of questions come in, but we're a little bit over time, so we'll have to respond to those via email if that's okay. Thank you everyone so much for joining us today. You guys have been a fantastic audience. If you have any other questions or need more information, please feel free to contact us. Sushil and Nishant's contact information is up on the screen, and we will be sending a recording of the webinar out in the next few days. You may also visit our website at keltontech.com. Thank you.